Hey there, welcome to Wagner Academy's SAT Math question number 63. This one says P and Q are two different positive integers. So if I can assume that P and Q are positive integers, I'm assuming things like P and Q are possibly 1 or 2 or 3 or 4 or so on. And it says P is greater than Q. And then it says if P squared is minus Q squared, the difference of the squares of their values is 17. What is the value of PQ, or P times Q? So I'm going to list off the positive integers first of all. So the positive integers I could have. 0 doesn't work. It's not a positive integer. It's not positive. It is an integer, but it's not positive. No negative numbers are going to work because they're not positive. But the first positive integer, that's 1. And then 2 and 3 and 4 and 5 and so on, just going up by 1 each time. I'll go up to 10. We could keep going, but I'll stop there. Just put a little ... and their squares, that's what we're concerned with here. Trying to find that the difference of squares being 17. So the squares of these values, that would be 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. 16, 25, 36, 49, 64, 81, 100, and so on. So we're looking for where we see a difference of squares, that's this part right here, being equal to 17. We can pick any of these two numbers, or any two of these numbers, to find a difference of 17, and I notice that these two would do that for me. The difference of 81 minus 64 is going to equal 17. And so what values, what corresponding positive integers do we have with those? That would be 8 and 9. So what is the value of PQ? Well, it says that P and Q, two different positive integers, P is greater than Q. So P would be the bigger one, would be 9, and Q would be the smaller one of those two, 8. But when we multiply them together, that doesn't really matter which one's which. P times Q would be 9 times 8, which would be 72. So for this one, the final answer is choice E, 72.